We're going to start a presentation included in the cycle of Conference of the Smart Cities, Intelligent System and Energy and Transportation, promoted by Indra Shade. In this conference, Dr. Oneto, a professor of computer engineering at the University of Genoa, will talk about how generative AI marks an important turning point in the development of artificial intelligence, with a strong implication for industries and society, as everyone is seeing in television, and even with our students and the work that we are designing every day. In this end, this seminar is going to offer a comprehensive exploration of fundamentals of generative AI, its application, and the ethical and regulatory landscape surrounding its use. The speaker, Dr. Luca Oneto, was born in Rapallo, Italy. He is an electronic engineer at the University of Genoa, and in 2014 he received his PhD from the same university with a thesis learning based on empirical data. He is an associate professor in computer engineering at the University of Genoa, co-founder of a spin-off called Zenabytes, and in 2019 he obtained his qualification of full professor. He has been involved in several European projects, and he has been awarded with the Amazon AWS Machine Learning as the best Italian young AI researcher. His main research topic is the statistical learning theory, with particular focus in the theoretical aspect of the problem of semi-supervised model selection and error estimation. He also is interested in data science, especially in the problem of trustworthy AI and the solution of real-world problems, improving the state-of-the-art learning algorithms and the theoretical result in the field of machine learning and data mining. Thank you, Luca.
Thank you. Hi to everyone, I'm Luca Oneto, okay? And today I will try to give a bit of an overview of what is generative AI, okay? Starting a bit from the context of artificial intelligence and machine learning, its development toward deep models, then generative AI, what is prompt engineering, the risk of using generative AI in real-world application, and the regulation framework, okay? Of course, I am a technician, okay? I'm not a lawyer, I'm not an historical guy, okay? But I will try to give a sort of overview on all these topics that are nowadays very important to understand what is going on in the industry, okay? Of course, this presentation is already outdated because 2 days ago it came out ChatGPT, the new version, and Gemini, the new version, but it's like this. So even if I update it today, tomorrow will be again late. So it's impossible to stay up. Okay. Again, I will try to be quite I try to be as clear as possible, try also to give a framework of what I'm talking about, okay? And the nomenclature that I use, and also my point of view on all these things, to try to put everyone on the same position to understand what I'm saying, okay? So what are we talking about when we talk about AI, okay? When we talk about AI, actually, we are talking about something that is a subset of the problem of knowledge representation and manipulation, okay? Which is something that happened from some, not century, but thousands of years by the humans, okay? That try to acquire knowledge and pass this knowledge to the next generation, okay? So our effort as humans, okay, is not just to understand something and pass this information through the genes, as animals do, okay? But also using this, representing this knowledge and let the new generation to learn from what we learned in the past, okay? Artificial intelligence is an effort, okay, to automatize as much as possible this process of representing the information and manipulate it, okay? So artificial intelligence is just a way to replicate what humans are doing from centuries, okay, using books, using whatever, but using instead machines, okay? Artificial intelligence is a very big concept, okay? and basically everything that has been done by a computer can be described as artificial intelligence, okay? But actually modern artificial intelligence is based mainly, so 99%, on machine learning, okay? So machines that learns based on data, okay? So the simplest example, you give to a machine 10 photos of an apple, 10 photos of a pear, and the machine needs, from this example, to recognize pear from apples, okay? A subset of the machine learning problem is the so-called deep learning problem, which is machine learning applied to specific signals, okay? What are these specific signals? Are signals that are good to be processed by the human brain. So, for example, text, okay? Images, voice, sequences, and so on. So, structured data. It's called in the literature, okay? And generative AI is a small part of deep learning, okay? Clear? AI didn't born with ChatGPT, okay, but born a bit of years ago. In particular, his father is Turing, so we are in the 1950s, okay, with a book, a paper that he wrote, Can Machine Think, okay. Everyone should know the history of Turing because of the film that was quite viewed by the people, The Imitation Game, okay, and how Turing developed a machine able to decrypt Enigma, which was the machine that encrypted the messages between German people during the World War II, okay? And the idea in that moment, the idea of artificial intelligence in that period was to try to improve the ability of the human brain where the brain lacks most, which is basically the speed, okay? Our brain is able to do very complex things, but it requires a lot of time to be done, okay? Instead, machines are usually quite stupid, okay, but they are extremely fast, okay? The sense that they know how to do things very fast, they do a lot of computation in a small amount of time, but this computation is simple, okay? When Turing managed to break the Enigma code, there was a first peak of, let's say, enthusiasm, okay, among the community of researchers or in general the scientists, okay, until there was the first AI winter in the 1970s, okay, due to the fact of two main facts. One is that the power of those machines was too limited for the problem that the researcher asked to the computer to solve. And the second is that the AI developed in that moment was based on a specific type of AI, which is called nowadays the old-fashioned AI. So the idea to try to model how the brain works and then use this model to solve specific tasks, okay? So people were trying to understand how the brain behaves, create a model of this brain, and then use this model, for example, to do face recognition, okay? This is the usual way in which science worked until then. Okay? Imagine the theory of Einstein. Einstein didn't want to predict the travel of Mercury, okay? But he wanted to understand the theory that regulates the gravitation, okay? And then the specific case of that theory is how Mercury runs around the sun, okay? That type of AI in that period was built on this concept, this illuminism concept, okay? Where basically we need to understand the whole thing in order to solve a specific problem, okay? So, first AI winter, because the machine didn't manage and the AI didn't manage to solve these problems, okay? And then there was a second rise with the development of the first expert systems, okay? So systems that worked on the same principle of the Turing machine on specific tasks. So I want to solve a very specific task. I don't want to model all the brain. I want to construct a machine that is able to emulate the behavior of the brain for just that particular problem, okay? Again, after this rise, okay, there was a second AI winter because basically they tried to apply this concept, for example, to solve the chess game, okay, but they didn't manage to do it, okay, because also trying to modeling how the brain works, okay, in a specific task is too complex to be done, okay. Again, for the machine of that period, okay. Now chess can be solved by a student of master degree in a thesis, okay, clear? Then after the 80, what happens? Machine learning comes out, okay. So the idea that we don't want to understand anything about how the brain works, but we want just to solve one specific topic. So we learned in the 80s that we cannot understand the general theory of the brain, okay? So we want to solve one specific topic, but we don't want to solve it understanding what is happening, okay? But we want to solve it learning from examples, so learning it from data. So in a statistical way. It's okay for us a black box that is able to solve that specific task, full stop, okay? From here, every 10 years, what happens is that some researchers predict that there will be a next AI winter, and instead it doesn't happen. Why? Because after machine learning, AI, deep learning rised. After deep learning, generative AI rised. Okay? And so no other winter is coming. Okay? But why is not happening this new winter? Okay? What is the difference between the old machine learning, the old AI, and the current AI that we are using? Okay? And for understanding these things, we have to go to the principle, as usual. Okay? When there is something in science, if you look back 50, 100, 200 years earlier, you will find a philosopher that started to investigate this concept, of course not from a technical point of view, but that actually managed to find the core of the problem, okay? And here we have the two philosophies behind artificial intelligence, okay? One is the one developed by Searle, okay, a philosopher that designed basically the concept of slow thinking, and the other one is Alan Turing, that I already talked about it, okay? What is the difference between these two philosophies, okay? The idea is this one. When we want to solve a very complex task, okay, as humans, we are extremely good at doing that with the so-called slow thinking, in the sense that a guy spends his life to solve a specific research question, or many generations of researchers focus on the same problem, and with incremental knowledge, they manage after 100 years, with 3-4 generations, to solve that specific problem. This is called slow thinking, so the capacity of human to understand things, not solve things, but understand things, okay? In order to support this way of understanding, of describing intelligence, Searle developed the so-called Chinese room argument, where he puts inside 2 rooms, in one a machine and in another one a human, and he asks to both to learn how to translate from Chinese to English, okay? What happened? After a few minutes, the machine was able to at least give a reasonable translation from Chinese to English. In the other room, the guy, after years, he was not even able to say, "Hi, I'm Luca Oneto," okay, in Chinese. Why? Because intelligence cannot be measured simply with the ability to solve a task, okay? But intelligence, for Searle, needs to be measured by the ability to understand the task. The machine was not actually able to understand anything about nor Chinese nor English, but was able to perform the task in a very fast way. Okay? Instead, Turing conceptualized, without actually knowing it, the other way in which humans think. Okay? When you go in a car and you want to turn on the car and start to ride, you don't start to say, okay, now I turn on my key, then the electricity goes in the motor, that starts a scribble that starts the engine. No, you simply go, tum, 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 and you start to go, okay? Why? Because in that case, you don't use your intelligence. You use your, let's say, memory of your brain that is able to repeat a task in a very fast way using basically correlation. So the idea that repeating a task multiple times, it becomes some part of you, basically, okay? So it connected the intelligence not with the ability to understand things, but to solve things. The imitation game, this is the idea behind, okay? Can machine things, okay? Has been answered by these two researchers in a completely different way. One with the ability to solve a particular problem. The other one to understand the things that it was doing, okay? And the concept between these two ideas, philosophical ideas, have of course a technical representation. Searle talks about causality, okay? While Turing talks about correlation, okay? In the sense that we know that if there is sun, there will be a lot of people eating ice cream, okay? And a lot of people also drowning, okay? Why? Because they go to see more people, and so in percentage there is more people that drowns, okay? But if you don't understand what is happening, okay, and you want just to predict how many drownings there will be or there has been today, or how many ice cream has been eaten today, okay, you simply can look at the other variable, and there is a correlation one-to-one between these two. Of course, there is no causality, but you can predict the other by just knowing one of them. Of course, this is a stupid example, but since I am in electrical engineer department, okay, let's take this one. These are the bachelor degree in engineering in the United States, if I don't remember wrong. And the other curve is the electricity generated in Cambodia, okay? And there is a correlation one-to-one. So if I know how many bachelor degree will be awarded next year, which is simply to measure, I go in the University of the USA and I say how many people are at the third year, I know exactly how many will take the degree next year, or at least with a precision that is below 1%, that is above 99%, okay? And I can predict exactly how many electricity will be predicted in Cambodia, okay? Now the question, of course, is, can I trust about this model? Okay. An electrical engineer will answer to me, of course, no. Okay. But I am a data scientist, and I say, okay, for 12 years it worked. I would try to do also for the next year. Okay. And the answer is this one. Okay. In the sense that this, of course, is a wrong model. Okay. But actually, all the models that we are using in real life, from engineering to physics, are wrong, okay? But some of them are useful, okay? I ask you a question. The Newton law is correct? Yes or no? It depends. If I am your student and I go to your class and you ask me the Newton law is correct, and I answer it depends. Of course, no. Okay, but the answer is correct in the sense that if you apply the Newton law on Earth, is correct. The sense that the answers that it provides fits with my experiments. Okay. But if I apply the Newton law to the Mercury traveling around the Sun, it will not work. Why? Because you have to use the general relativity that tells that the space is not straight, is curved, and is curved because of the presence of a big mass, okay? And so you need to take care of this curvature, especially when you are close to the Sun. So if you apply the Newton law to the Earth, it works. But if you apply it to Mercury, no, because it's too close to a big mass. Okay? Another question. Math is correct? Einstein is easy because you can see it on the serial below. You know that exists Newton? But let's ask something a bit more complex. Math is correct? I ask the question more technically. Math is based on axioms, right? Are axioms correct?
Yes, they've been tested so many years.
Wrong. Do you know what is Hilbert, all of you? He wrote on his, let's say, epigraph on his death place, okay, a phrase, we have to know and we will know. So the answer to this question from Hilbert was that sooner or later someone would be able, okay, to prove that the axiom of mathematics are true. We are in the 18th century, not 2 million years ago, okay? So Hilbert comes from an illuministic vision of the world where humans sooner or later would have been able to answer to all the big questions of science. And one of them is to prove that the axioms are correct, okay? In the 20s, a mathematician, Gödel, proved a theorem that is called the incompleteness theorem that proves that you cannot prove the veridicity of the axiom. Dot. Okay? In the sense that the actual statement of the theorem is that a consistent system cannot be used to prove its consistency. Okay? So, we don't know, maybe in 200 years, 2000 years, we will find a contradiction, okay, in math that will tell us that the axioms are wrong, okay? Clear? It may happen. The probability is quite small, but it may happen, okay? So this phrase that seems to be a very simple or naive phrase hidens centuries of research, okay? And this statement is something that a machine learner, a guy that currently is working on AI, embeds in his brain and in his way of thinking to approach life continuously, okay? We will see why, okay? In fact, what happened in the 80s, okay? You remember the winters? What happened in the 80s with respect to what happened before in the AI? We simply took a shortcut. We stopped asking to ourselves, okay, how how human works, or if machine can think, okay, and we simply take a shortcut. We want to solve one problem at a time, trying to find correlation. Stop. Okay? So use machine learning. Okay? And there was many papers, very, very important. This is a book, quite divulgative, by Nello Cristianini of 2 years ago that talks about this fact. But there is also papers, okay, of 10, 12 years ago about a researcher that was so puzzled by the fact that machine learning worked so well. So stopping understanding what is intelligence, stopping understanding how brain works, stop questioning ourselves about the intelligence of machines, and simply try to solve one problem at a time using data, that they started to ask to themselves, but how can this work? How machine learning can work? Okay? Now we see a bit why it works, okay? So we focus on these 3 balls: machine learning, deep learning, and generative AI, okay? So simply, we don't care about understanding how brain works, what is intelligence, or whatever. We want just to solve one problem at a time, okay? And what kind of problem we are able to solve with machine learning, okay? One simple problem, just one. We are just able to solve one problem. If we have data like this, which are the simplest one that we can imagine, so tabular data, okay? So we have observation on the lines, okay, and variables on the columns, okay? So the so-called examples, okay? We can do something like that, okay? We can put the points, okay, in a space which is in this case bidimensional, but can be huge dimensional, 10 to the power of 12, 10 to the power of 20, okay? On each point we assign a label, for example, in this case, healthy, sick, or the machine will work in the next 10 months, the machine will not work in the next 10 months, or what is the next word after this piece of text, or what is the next move in this game to be done, okay? And then we search this line, okay? So something that is able to separate one class from the other, okay? Stop. This is the so-called linear models, in this case, predictive models, which is called discriminative, okay? Clear? So we constructed the linear because there is a line, discriminative because we want to say green against red, but it can be green, red, purple, or it can be a number, nothing changes, okay? And shallow because we are working directly on the original data, okay? Clear? How can we find this straight line, okay? Because of course here it's easy because if we are in 2 dimension, but if we are in million dimension, we cannot see the data, so we do not know what line we can put, okay? So, how do we choose that line? With a very complex approach, with a lot of smartness, with the complex math? Answer is more or less randomly. We test many lines until one fits well, okay? Some of you that knows better machine learning say, no, I don't use random. I solve a linear system of equation, so I found exactly the perfect one, okay? You are right with 1,000, 10,000, 3,000 data, okay? When the data are 3 or 30 million, trillion, okay? You cannot do that, okay? So what you use gradient descent, okay? So you don't use the exact solution, but you iterate, okay? But when you iterate, what happens? That you have to split the problem, so you will not reach the global minima, okay? And sometimes the problems are not linear, so you start from a point, you go to the closest minima, so basically it's random search with a bit of smartness inside, okay? Clear? So, machine learning, linear, discriminative, shallow, okay? Every word has a meaning. Linear, because it's linear. Discriminative, red, green. Shallow, because I work directly on the tabular data, okay? Then we can do something a bit more smart, okay? Because the word is not linear, okay? But since we have a number, we want to use always a number for everything, okay? To cook an egg and to kill a mosquito. I have a number, I want always to use the same tool, okay? So I discovered that I can apply a nonlinear transformation to my data, okay? That phi, and do linear model with that nonlinear transformation. Then we discovered that 200 years ago a guy called Mercier, okay, discovered a function called kernel, so you can do this even without doing your projection, okay? Is it good this? Yes, of course, because basically you don't, if the dimension of your data are already big, you don't suffer the course of the dimensionality, okay? Clear? And then we invent many approaches. For example, kernel methods, I already said, random projection, so again, randomness, okay? The phi, how can I design the phi? I don't know, I put random things, okay? Or ensemble methods, okay? So I use the wisdom of the crowd principle. So I use many simple classifier, not maybe many linear model, okay? And I take an agreement between that, okay? With different approaches like bagging or boosting. They are different flavor of the same thing, okay? But what happens when my data are not tabular data? Okay? What do I mean about tabular data? They cannot be represented with the table. Okay? And then, of course, you are an engineer, you say everything can be represented with the table. Okay? In the sense that an image is a series of pixels, so I can transform it in a vector, so in a table. Okay? No, because you miss what? One information, the locality principle. Okay? You are not saying that this pixel is close to this pixel. Okay? Or a graph can be represented with a vector, the adjacency matrix. Okay? Yes, but if I move two nodes in a graph, so the graph remains the same, I just move these two nodes. Okay? I obtain another adjacency matrix. How can I check if these two graphs are the same? It's impossible because it's an NP-complete problem. Okay? Or a text. Okay? There are a million ways of saying the same phrase. In Italy, there are 3 million. Okay? In English, it's just 100. Okay? In Spanish, I don't know how much, but something in the middle, I think. Okay? So, how can I say that the two phrases are similar? Okay? So the problem when you have structured data, okay, so not unstructured data, so data that have not just a value to be represented, but also connection between values, okay? How can I code also that information, okay? And for this, we have problems, because we know just to do linear models on data points. Okay, it's the only thing that we are able to do in machine learning, okay? And so, we have a hammer, we want to continue using the same hammer. So, try to translate the graph, okay, or the text, or the image, in a vector, okay? How can we do it? We can do it in 2 ways. The first way is to call an expert of the domain, okay? Which tells me this graph that represents a molecule actually can be represented by this information. If there is this kind of ring in the molecule, for example, which represents benzene, okay? Or if there is a connection with a particular node which is important for your application, okay? And so you can manually extract a vector of information from this mess, okay? Of course, this is not scalable, okay? Why it's not scalable? Because, first of all, not for every problem we have an expert able to tell us, okay? If it exists, maybe it's too expensive, okay? In the sense that there are few of them, in one case, or they ask a lot of money to give the answer, okay? Clear? Third, is time consuming. Okay? In the sense that even if he's smart, is the smartest guy, I have a lot of money, okay? It may take 1 year to develop a good representation vector if the problem is not trivial, okay? But if it is trivial, I can do it as a computer scientist. I don't have to call an expert, okay? And this part, so manual feature engineering here, is something that worked until 2005. It's not something that we stopped doing it 100 million years ago, okay? Until 2005, the state-of-the-art approach to solve a real-world problem was this one, okay? And even today, there are many applications, for example, condition-based maintenance and things like this, that beautifully worked by just using a fixed representation from an expert, okay? Clear? When this cannot be done, okay, we need to learn this representation from the data, okay? What do I mean about learn this representation from the data? We need to find a vector that is able to well represent that structure, okay? Clear? How can be done this? The first attempt was really easy, okay? I take my input data, I try to represent it in a vector, and I try with this vector to reconstruct the original data, okay? Clear? So basically, I transform the problem of learning a representation in a discriminative problem, okay? So try to find a function that passing through a vector is able to reconstruct the original data. Clear? Very easy, okay? Then things, of course, get messy, okay? And people developed a lot of neural network, they are called, able to do this, recurrent, many things, okay? Clear? Among these mess, what are the concepts that they use? Actually, they use just two concepts, all this kind of neural network. Convolution and attention, nothing else, okay? What is convolution? The convolution is the idea that when I look at the structured data, I need to code one important thing, the most important thing, the notion of locality. So things that are close to each other probably have a meaning. So I don't have to react to all the structure. I have to react to portion of the structure, okay? A convolution is exactly this. So I don't look at the entire set of data, in this case is images, because of course convolution are used mostly in images, okay? But I just react to a piece of the image, okay? Clear? And why convolution and not something else? Because convolution is something that we know how to do it from 200 years, okay? So we have a hammer and we continue to use the same hammer, okay? So convolution is not the only approach, but is the simplest one and the one that we know better, okay? It also has a biological explanation in the sense that in our eyes, the piece of the brain that transforms the images in something that the brain elaborates, it's a Gabor filter, okay? Which is a convolution, okay? Is it okay? The other problem is attention, okay? Because if I use convolution, what is the problem of convolution?
Maybe too small. The image maybe too small.
There?
The image maybe too small.
No. It probably is correct, yeah, if I understood correctly. No. The data, you need to have a lot of data always. So.
I mean, like, you have a picture of let's say, ear, and it's too small, and you need like to.
You are there almost, okay? The idea is that the problem of convolution is the convolution, the fact that it reacts to small pieces of the image. Meaning, if two concepts are far away from each other, okay, you cannot merge it because the convolution does not react to large-scale piece of the image, okay? So you need to use attention. So attention is the idea that after you are able to extract information in places that are called local, okay? You have to merge this information together. So you need to react to things that are far away from each other. And this is the concept of attention, okay? Turns out that actually you can do something even smarter than this, okay? In the sense that Google developed a neural network able to well represent the images inside the internet when you ask for an image in Google Image, okay? Then I need to detect if my machine has a problem with the images, okay? It worked on internet. Why I cannot use the same representation also to detect faults in my machine? This is what is called transfer learning. So once you train the network, okay, to solve a big problem, like for example Google Image, you can reuse this network to represent well images for other problems, okay? In fact, Model Zoo. There is online a repository of pre-trained network, okay, made available by large tech companies like Google, okay, but also by researchers, that you can reuse, okay, and you can see that they are very big network, for example, 40 megabytes of weights, okay, that try to embed simply an images or a text or whatever into a vector, okay. So what we do is to transform basically the problem that we had before in something again linear. So I take my image, my structure, okay? I put it in something that translates it into a vector, and then I put a linear or a nonlinear model on top of this representation. Full stop. Okay? Clear? How can I do it? Again, gradient descent, both for representation and both for learning the model. Okay? I can use many ways of doing gradient descent that are smarter or less smarter. Okay? The problem needs to be convex or at least differentiable. If it is not differentiable, we cannot do anything. Okay? The problem must be horizontally separable. It means that I want this optimization problem to be that can be solved element-wise. Okay? And then we can do it parallelly using hardware that has been developed for playing games, so the GPUs, okay, that are able to do a lot of simple computation but in parallel, okay? And then we simply brute force intelligence, okay? In the sense that now we have a very complex tool that is able to translate things that seems to be full of need for intelligence, okay, in something that is just optimizing some weights in order to find a good line, nothing else, okay? And how we did it? We collected a lot of data, we datified the reality. There are sensors everywhere nowadays, okay? When you build an infrastructure for industry, it's sensorized. When you go to the street, there are cameras, intelligent semaphores, some sensor in the street itself, okay? When you have a smartphone in your pocket, you have a GPS, you have accelerometer, you have a microphone, you have temperature sensors, okay? So you can also detect, for example, change in temperature of the body. This is wow, for example, they built the app for the women to detect, to predict the cycle, and so the pregnancy, okay? Using the temperature perceived by the phone, okay? And stuff like this, okay? So we need a lot of data, because the more weights you have, basically, the more data you need in order to find a good configuration of the weight. We have a lot of computational power, okay? In the sense that the computational ability of this machine grows exponentially during the years, okay? In the sense that every year it doubles, triples. This year, for example, the new architecture of NVIDIA is 10 times faster than the previous one, okay? So in 1 year, 2 years, 10 times the computational power, okay? There are a lot of people that are using AI, okay? Basically, if you go in whatever field, scientific field, okay, everyone is using somehow AI in his research. And there is a lot of people that is investing in this research, from companies, imagine, of course, Google, OpenAI, and whatever, that invested the trillions, okay? But these are the numbers of investment of China, United States, and rest of the world, okay? In the sense that there are $1 trillion every year, okay? So transforming intelligence, okay, in something that can be brute forced, okay, is from one side, of course, a shortcut, okay? But from the other side is the only way we have as human to actually address a problem without using intelligence, but just by using brute force, so by using technology, okay? So we transform the philosophical problem into a technological problem, okay? In the sense that now, if I want to have a better machine with more ability to solve tasks, I just need to put or more money, or more data, or more computational power. Done. Okay? The things that you saw before, for example, attention convolution, okay, now are common because everyone read about it somewhere, okay? And so people say, but yes, they have been discovered from few years, okay? Convolution has been discovered in the 1970, okay? And attention in the 1972, okay? So 50 years ago. Now became, of course, let's say, famous because they worked. But the idea is not something that has been discovered now, but is known from 50 years, okay? Now we have the computational power to make it work, okay? And then finally, we arrive to generative AI, okay? So we want to make this step forward. We say, okay, we are able to do the discriminative well on whatever data by just putting enough data and enough computational power. I want to do generative. What is the difference between generative and discriminative? Okay? Generative, from one sense, is very simple. I take a point, I move it, okay? And I say I'm still in the right class, then this point is still a possible point, okay? Imagine, for example, that this is a trading, okay, that resulted in a bad outcome. So I made this trade and I lost money, okay? Instead here, I move this point, this is a good trade, I'm still in this position, so this is a trade that should bring me to a good outcome, so I gain money, okay? What is the problem when I move this point here? That point may not exist, okay? Not all trades are possible, okay? In the sense that I cannot, for example, buy Google. Okay, it's a possible trade, but I don't have the money to buy Google, okay? So, if I simply use this idea, so I have a model that discriminates between bad and good. So if I move in the region where it's good, I generate a point that may possibly lead me to good things. If I move in the region where there are bad points, I generate possible move that probably will bring me to bad outcome, okay? So I need this other thing here, okay? What is this? Is the region of possibility. So I can move my points, but only on possible things that I can do, okay? Clear? So here, if I look at this, it seems to be a sort of constrained prediction, okay? I just need to put that constraint, okay? I move that point, but the point should be inside the green ball or the red ball. Clear? This does not work. Why? Because I don't know what is the region of interest, okay? Clear? So how can I solve it? Let's see how the people solve it here, okay? This is the two main results of generative AI, okay? One is AlphaGo, okay? AlphaGo is a machine developed in 2016 that was able to win against the world champion of Go. Go is a game like football for Spanish or Italian people, but in China, okay? In the sense that they like to play with these small piece of things, black and white, like chess, but there are the chess table is much larger, okay? And there are only two things to move, so white pieces or black pieces, okay? And it has been considered until the 50s, okay, the most important challenge for AI, okay? In the sense that it's the most complex game, computationally, of course, that has been ever designed by humans, okay? And this guy here, which is called Lee Sedol, is probably the best Go player in history, okay? He's considered the best Go player because he plays like Messi, okay? Not just wins games, but also as it plays with innovative action for the other players, okay? It has been beaten in 2016 by this machine, okay? That actually simply predicted the next move, okay? So they translated the act of generation in an act of prediction. So in every moment of the game, the machine simply predicts what is the move that most likely will lead to a win. Okay? And why it's discriminative? Because simply you go back in the old game played by the players, okay? And you know the outcome, because you know who win the game, and you know the next move. So you simply need to find a good representation of a move, and then there is a line that tells what is the best one. Full stop. Okay? So they simply jump the fact to generate something, and they transformed the generation problem into a problem that is the only one that we are able to solve. Prediction, discriminative. Okay? Here, and we will go to this concept later, if you go on YouTube, there is a documentary on this thing that is called AlphaGo Movie. Okay? There is a particular moment in that documentary where basically the machine makes a move, and inside the room there was Messi, Pelé, Maradona, all of these, and all starts to smile, okay, and to say AlphaGo is completely crazy, okay, because he made a move that no human would have chosen as next move, and so everybody starts to smile by saying it's completely crazy. After other two moves, they discovered that that move was a genius move, not as beautiful as the one chosen by the human, but impossible to beat by a human, because whatever the human would have done, the machine would have always be 1 or 2 points more of the human. Okay? ChatGPT, okay? Today, we all refer to ChatGPT as a human. Let's ask to ChatGPT, okay? Or what ChatGPT thinks about it. Oh, it's very intelligent, ChatGPT, okay? And what actually does ChatGPT under the hood? It simply takes your question and predicts the next word. Actually, neither the word, the next 3 digits, the next 3 letters of the move. Then it takes your question, the 3 things that he predicted, he put it as an input, and it predicts the next 3 letters again. And it iteratively do this. Okay? Clear? So again, ChatGPT is nothing generative, is discriminative, purely discriminative. Okay? How it has been trained? With all the text generated by human and digitalized by the beginning of the humanity. Okay? Stop. Okay? What is the definition of generative AI? Okay? The definition of generative AI is a branch of AI that focuses on creating and generating new content, image, text, video, or other forms of media using machine learning examples. Okay? So this is the description of generative AI. Okay? And in fact, here there is no words like constraint, knowledge, representation. There is simple machine learning generation. Okay? How many modalities there are for generating things? The main inputs, okay, are text and images, the main 2 things, okay? Now people, they say that is also able to accept audio. Is not true. The audio is simply translated into text, and then the text is provided to ChatGPT, okay? And then as output is produces text, images, audio, or decision, okay? Today is a bit more complex than this, in the sense that the ChatGPT is multimodal. Okay, what does it mean that it's multimodal? That accept a bit of text, a bit of images. Okay, how this works actually is not something very complex. There are two representation vector. One takes just the text. One takes just the images. Okay. It creates 2 vectors, concatenates with each other, and the prediction is simply or the next token or the pixel of the images. Okay? Nothing else. Of course, there is a boom in generative application and platform and tools. You can do whatever you want, okay? This is the landscape updated to 2 weeks ago, but probably if I found the same landscape is double today, okay? But what are the techniques behind generation, okay? So generative AI. Actually, there are 4 main approaches to do generative AI, okay? One of them is already updated in the sense that is always underperforming all the other 3s, okay? But the 4 one are generative adversarial network, variational autoencoder network, flow-based model, and diffusion model, okay? Let's try to understand a bit how this works, okay? Let's start with the generative adversarial network, okay? The idea here is very simple. You take a sample, okay? And you try to discriminate between something good or bad, for example, okay? So this sample is healthy, this sample is sick. Or this sample is a good functioning of the machine, this sample is bad functioning of the machine, okay? Then, what you do, you try to use that model on the opposite side, okay? Instead of using the image to predict the outcome, you use the outcome to predict the image, okay? So instead of flowing the information from here to here, you flow the information from here to here, okay? How can you do it? It's very simple. It's a function, it's a feed-forward function, okay? So you can do gradient descent on the weights, okay, to optimize the weights, or you can do gradient descent on the input to optimize the input, okay? Very simple, okay? One can say, yes, but before you said to me that it's still discriminative. Instead, here is not discriminative. You are touching the network. Absolutely no, okay? In the sense that the idea is always the same. You move the point, okay, and you apply the discrimination, okay? But the technique to do this, in order to be smart enough, you cannot move the point, because the point can be moved in infinite position, okay? So it would be very slow to move the point until you find a good configuration, okay? So the smartest thing to do to move the point is to do gradient descent on the point instead of doing gradient descent on the weights, okay? This born actually in another field, this approach, which is the field of adversarial machine learning, okay? Imagine to have, for example, a machine that tries to predict if an executable or an application of the phone is a malware or not. Or try to imagine a machine that looks at the packet that flows in your network and try to predict if there is an attack going on in your network, okay? This is very good from the point of view of the defender, because I want to detect if someone is intruding my network or if someone is trying to install to my phone something that is not legal, okay? But look at the point of view of the attacker. The point of view of the attacker is what? Is to try to modify as small as possible your input in order to be able to induce the machine into mistakes, okay? Clear? And the idea of generative adversarial network is actually this. Instead of trying to induce the network into mistake, you are trying to induce the network in telling you what is the best image that will be labeled by a human as a good image, or to induce the machine to generate a word that will be labeled by a human as a good word, starting word for the answer. Okay? The second approach is variational autoencoder, okay? And what is the idea? The idea is quite simple, no? If I take my image and I encode it into a vector, what happens? That if I move even slightly my point in this new space, this may correspond in the original space to something that is very bad, okay? Impossible. What I said before, no? I move into a point that is not a cat, okay? But if I manage to encode my picture in something that is, for example, a Gaussian, or nearly a Gaussian, okay? So this image can be plugged into a series of points that still seems like a Gaussian. I just need to apply some noise here to reconstruct, again, a cat, maybe slightly different, okay? This is the idea of variation autoencoder, so to construct a vector space that has a sort of property of Gaussianity, okay? Based on this approach, had been discovered the other approach, which is the diffusion model. The diffusion model tells I want to have for each image something that can be represented with a Gaussian, okay? Then let's transform every input to a Gaussian, okay? In this way, if I apply noise in the latent space, so in the embedding space, in the representation vector, okay? And I go back using gradient descent, I will be able basically to represent everything in a good way, okay? There are, of course, technical things behind. It's not so simple, okay? Because being able to translate everything in a Gaussian without compromising the meaning is not simple, okay? But it's just technicalities, okay? Actually, the idea is this one, nothing more, nothing less. And what are the architecture to do this? So what are the pieces behind? So how the discriminative model is built inside, okay? If you work with images, actually it's just convolution. So it's a concatenation of convolution horizontally, so they make the network bigger, so more deep, or vertically. So they use different convolution at different levels. This is called inception, okay? If instead you want to deal with text, okay, what you have to do is to use the transformer, okay? And what is the transformer? Is just the application of attention, okay? In the sense that what is the problem of a text? The fact that words that are related with each other can be close to each one or far from each one, okay? So you don't need convolution because it doesn't make any sense to compress the information that is close because the information can or cannot be close to each other. But you need to put in relation things that are far away from each other, okay? Actually very far away. Imagine, for example, to provide to your network a chapter of a book. Okay? It can start with the subject of the book, then there can be a description of the country or whatever, and then it can restart the story. Okay? So the information can be even pages away. Okay? So it's just a concatenation of attention. Okay? Nothing else. These things in the middle are normalization. Okay? What is the problem of normalization? Is just the fact that we need to optimize with gradient descent, so we need to always compress numerically this representation in a way that is always excitable by the gradient descent. Okay? What came out from the generative AI field? The foundation model. So pre-trained network to do generation. So the equivalent of the model zoo that we saw for deep learning has been developed also for generative AI. So people made available this model that are able to plug the input space into a representation vector. Okay? Moreover, today they also give to you the other pieces, so the piece that do the task specific. So for example, answer questions, sentiment analysis, extract information. So they do not just provide to you the pre-trained network for representing, for plugging your structured data into a representation vector. But they also provide to you the last layer that is able to do question answering, so the task-specific problem, okay? Because these are so important if you want, for example, in your company to construct your conversational model, that you cannot train from scratch your conversational model. You start from the one already built up, and then you fine-tune with the data of your company, okay? When the today generative AI born, they born in 2018, okay? Maybe some of you have heard about Word2Vect and BERT, okay? That are the origins of generative AI. And then they invested a lot of money in the different approach, you see, encoder, decoder only, the one that I showed you before, until they reach ChatGPT. This street died one after the other, and today the most adopted approach is the one of, at least for text, of encoder-decoder, okay? Now we can better understand how AlphaGo and ChatGPT works, okay? These are the answers of ChatGPT if you ask, please, describe to me how AlphaGo works, okay? How AlphaGo works, it collected data, okay? So it collected the data about many Go gameplay. Then it trained the neural network to predict the next move. Then, what it did, I hope that nobody thinks really that the output of ChatGPT, so the next prediction is just provided to the user. It's not like that, okay? In the sense that, for example, in ChatGPT, the first version plugged the text into an automatic grammatical corrector. And then it always worked in English, and it used the translator to translate the question and the answer to the specific language, because they didn't have enough data for each languages, okay? So actually the prediction of the neural network is inserted in a very simple thing, in a so-called Monte Carlo tree search, in the sense that it predicts different move, no? Because when I predict this move is good, it may say yes with probability 0.5. I don't trust. So I ask another move. At the end, I have 3 or 4 moves that may be the luckiest one, okay? But I don't trust the prediction of the neural network. What do I actually do? I try to implement this move, and then I use a fake player, so AlphaGo itself, to make the next move. And so I let the machine play with itself for 10, 15, 20 moves ahead. And then I check what is the move that in this scenario led me to a win or to a loss. Okay? Because what is the best thing about generative AI with respect to predictive AI? Predictive AI needs data, right? So you need a human supervision, or at least a supervision, okay? And what is instead the good thing about generative AI? That you can make 2 generative AI play with each other or talk with each other, okay? And so they can improve, if they start from a good starting point, they can improve themselves by simply play against each other, okay? Translation, generating other games, okay? Then once you did this search, you evaluate, okay? And then you decide if it is okay or not, okay? ChatGPT works exactly in the same way. You collect the data, you tokenize. What is tokenize? I said that you don't predict the next word, because words are too many, and they are all different length, okay? So I just predict the three letter next, because 3 letter is good, because the option are only 24 to the power of 3, okay? Then I train the model that predicts the next token, okay? And then what I do, where do OpenAI spend the large amount of money? In training the model? No. In paying people labeling the output of ChatGPT. So they were paying, I don't know if you heard about the Mechanical Turk of Amazon AWS. If you go, there is this service, there is 1 million of people for which you can ask a simple question. For each answer you have to pay 1 cent, 0.1 cent, okay? Of course, you are, it's not a good job for those, but how capitalism works, okay? So what happens is that they spend a lot of money in labeling how ChatGPT works. So they construct a model on top of the predictor one that tells this phrase is a good phrase, this phrase is a bad phrase, okay? So once you generated a different answer, you need a machine that tells between these different answers, that are all variation of the same answer, this is the best one, okay? This is why sometimes when you go to ChatGPT or Gemini or whatever, 2 answers appears, and in order to read the entire answer, you are forced to click on one of them. Because in this way, you are labeling, you are the Mechanical Turk of ChatGPT. You are labeling other samples for them, okay? Done. So now you should be able at least to have a grasp on how, or what is behind the scene of ChatGPT, okay? And here starts problem, okay? In the sense that ChatGPT is trained on data. Okay, on text. And where did they took this text? Everywhere. New York Times, Corriere della Sera for Italy, or in Spain there is, I don't know, some important newspaper, okay? But who wrote those things?
The prison group.
Huh?
In Spain is training with the prison group text. They are the editors of the...
Yes, but who paid for that text? Not ChatGPT. In fact, in the USA, there is a big lawsuit against ChatGPT from the New York Times because they said that you need to develop the version of ChatGPT without alt text because you didn't pay us, okay? Here I put an example of what is happening, for example, not in text generation, but in code generation. Of course, you can generate a specific kind of text, which is coding. Copilot, maybe you heard about it, all of you, okay? What is the problem of companies right now? I work a lot with Hitachi Rail, which is a company that produces pieces for trains, okay? And they say, okay, nice, but the code that is generated by this, can I use it in my product without being sued by New York Times or the people that generated the code to train ChatGPT? The answer is that basically most of these things are for sure the one that works better, are not trained just on open source code, but they are trained on closed source code. And then they cannot be used by other company, okay? So there is a problem of copyrighted text and licensed code, okay? That will be a huge problem in the next years, okay? For now, the people are going so fast that the regulation is not able to comply with, but soon there will be problems like this, okay? Now we have generative AI. What is the problem? Many of you have tried to ask to ChatGPT a question. The answer was dummy, okay? And then you say, okay, ChatGPT does not work, okay? And they stop using it, okay? The problem is that you don't know how to use ChatGPT, not that ChatGPT doesn't work, okay? And in fact, there is a field of research which is really important right now, which is prompt engineering, okay? What is prompt engineering? Is the art of asking the right question to ChatGPT if you want a good answer, okay? This will be outdated in 1 year time, in the sense that, as we will see in a few slides, right now when you ask a question to ChatGPT, ChatGPT takes your question, okay, and generate a good prompt associated with your question, okay? In the sense that he assumes that the question provided by the guy is stupid, as usual, the user is stupid by definition, okay? And try to fix the stupidity of the user, okay? What is the problem of generative AI? That if you ask a different question, you obtain different answer, even if the idea of the question is the same, okay? So, what happens is that there is this nice website, if you want to go, learnprompting.org. The problem is that when you use generative AI, you need to design properly your prompt in a way that the machine is able to answer you correctly, okay? And in particular, the prompt should be designed in this way, okay? You should give a context. You should give the instruction. If you have it, you can give some example to show to the machine what you are actually meaning, and then the actual input that you want to give to ChatGPT. Let's make an example, okay? Context. I am a researcher at the University of Genoa in machine learning, okay? I would like to understand better what is the diffusion model, okay? For example, I know how variational autoencoder works, and they works in this way, and I describe with my words how variational autoencoder works, and then I say, please, can you do the same for my question, okay? For example, here, these are two simple prompting. One is instruction prompting, okay? Write a catchy name for a store which sells toy, okay? And the other is role prompting. You are a famous writer for 2000. Write a short poem about freedom, okay? In the sense that you can tell to the machine also the audience or who is writing what. For example, if you ask to ChatGPT, please describe what is the theory of relativity, it will answer you something. Please write something about the theory of relativity, knowing that this will be read by a high school student, okay? Or write this text thinking that you are a comedian, okay? And the answer will change, okay? This is the idea of role prompting, okay? Of course, we are engineer and we use mostly instruction prompting, okay? So we describe exactly what we want and not the role in which we are, okay? Then there are prompting with and without examples, okay? For example, this is a zero-shot prompting in the sense that you don't give example, give the US city provided its state, okay? City, state, and the answer is Chicago, okay? One-shot prompting means that you give one example. For example, if I tell you Chicago, you have to tell me Illinois. Or if I tell you Strasse, you speed, cloud. Okay? Clear? Just a few shot prompting. Okay? It is important because they learn from example. Okay? In the sense that in this way he knows already how you want the answer and with what accuracy. Okay? Then there is the chain of thought. That is something that you already use almost. So you ask a question and then you say, okay, you answer me like this. I understood, but this part of your answer is not good. Can you improve it? So basically you generate a sort of chain of thought. Okay? How does it work in practice, this? He simply takes all the question and all his answer, and it concatenates all this text to your last question. Nothing else, okay? So it just changes the prompt, okay? Then there is self-consistency prompting. This is something that probably you have tested as engineer. You say, I give the same question posed in a different way, and I check if the answer is always the same. If it's not always the same, I take the majority voting among them, okay? This is self-consistency. Then there is general knowledge prompting, in the sense that you can improve your prompt by some external source of knowledge. For example, if you have a database of information of your company. Today is not called anymore general knowledge prompting, but is called RAG. Okay, we will see later. This is details. Today, people are using this. So basically, when you give a prompt, there is a generative AI substrate that before providing the prompt to the ChatGPT improves your question, okay? Then, of course, there is image prompting. Also in image prompting, you have to do the prompt correctly. You have to tell, for example, if you want to generate a photo, you need to say the photo style, the art type, and so on and so forth. If you are able to structure your question properly, the answer will improve, okay? The idea at the end of this prompt engineering is just to keep it simple, be concise, ask one task at a time, avoid to be verbose, and break down your complex task in simpler tasks. So divide ad impera, okay? Today, the frontier, okay, for example, where the companies are working and requires a lot of things, okay, in the sense 2 or 3 companies just in the last month asked to me this, is RAG, Retrieval Augment Generation, okay? What is RAG? RAG actually is something very simple, okay? You have trained your generative AI on New York Times, okay? But then you want your ChatGPT, for example, I take again the example of Hitachi, okay? Which is a railway company. So in the railway domain, a semaphore is not a semaphore, it's called signal, okay? In railway, the semaphores, okay, are called signals, okay? And this is an example. There are many other things to be known. For example, there is a specific legislation, there is a specific way of writing the code that should be seal 4, seal 5, seal 7, okay? So in that case, I don't want to use a general language model, okay? I want to adapt it to my specific context, okay? How can I do it? One way is to say, okay, I take this model, I take all my data, and I fine-tune this model with my data, okay? Yes, but it's Hitachi, it's not Google. They will not be able to do it, okay? Full stop. First of all, they are not even able to retrieve this data. Maybe they are PDF, they are in the brain of the people, different sources, so it's a nightmare. So what they do this RAG. What is RAG? When you ask something as prompt, before providing it to the large language model, okay, you start to retrieve with the tools that you already have in your company, for example, Active Directory or something like that, okay, all the information related to that question on your databases, okay? Then what happens? You filter a bit this data and you attach all this data to the prompt, okay? In this way, the large language model will see the question and will see all the things in your company that are related with that question, okay? You say, but this is a huge amount of information. Yes, and this is why, for example, now every time ChatGPT comes out or Gemini comes out, they say the prompt can be 40 mega, 80 mega, 90 mega, 1 terabyte, okay? Because, of course, the larger is the prompt, okay, the more you can do retrieve, for example, in a simple way, retrieval augment generation, okay? Clear? Okay. Now, more or less, we completed a picture of what is happening inside generative AI, where it comes from, and so on. The problem is that to make a generative AI, we take a shortcut, okay? And as it happens in life, every time you take a shortcut, sooner or later, you will pay the price for it, okay? This is the number of AI-related incidents in years, okay? Incident means that they impacted really the life of people, so people that went to jail because of AI, something like that. You see? Typical exponential, okay? This is dated 2023, it's a bit old, this one. It's a bit more, it's 200, the number of 2023, okay? Why this? Because the generative AI has been developed with the technical metric in mind, okay? So the idea to be accurate, to be as computationally efficient as possible, and so on and so forth. But we didn't take into account many other parameters, so security, explainability, fairness, privacy, cultural competency, okay? Which are the metrics that we actually require from a technical instrument, okay? If you take your car, you don't think every 2 minutes that maybe the car cannot brake if I press the brake, okay? You know that the probability of this thing is almost 0, okay? Because it's robust, okay? If you go to the bank and you ask for credit and they answer no, the first question is, why no? Okay? Otherwise, I suit you because you cannot tell me no because you like it. You have to explain to me why not. Okay? If I go to the bank asking for the credit, then I put some dark color on my skin, okay, and I go back again to the bank and I ask again for the credit, I want that the answer doesn't change. Okay? You say, obviously, right? Go in the website for making the come si dice, preventivo, for a quote for an insurance of your car, okay? Take 10 websites, okay? And ask for the quote with your data, okay? Then do the same by changing your place of birth and put, for example, Africa, okay? You will see that on average the prices will increase, okay? Which is of course illegal. You cannot do this, okay? Privacy. We said it before. The data of your New York Times cannot be used for training a network from which I use for making money, because I'm using your work to gain money. It's not correct. I need to give you the part that you deserve, okay? If you take a robot that has been trained to walk in a Chinese room, we try this, and you put this robot in Sweden, what happens? It starts to punch all the walls, to go down every time there is something on the floor, because the cultural environment is completely different. What is a lamp in Sweden is completely different from the notion of lamp in China, okay? The bed in Sweden are completely different from the bed in China, okay? And the problem is that if you maximize simply accuracy and computational requirement, this may not happen, okay? For example, here we are talking about discriminative AI, okay? This is was at that time, I was present at the conference of that thing, top face recognizer system. Now face recognition, for example, in some airport are used to detect you and make you pass toward the border, okay? So it's important. A guy in that conference arrived with a pair of glasses in the tool of the airport for detecting the faces. He put these glasses and the guy said, "Welcome, Donald Trump," to the airport, okay? So with the simple 3D printed glasses, you can make think that Meg Ryan is Zac Efron and vice versa, okay? Or if you put a sticker in the right position on a traffic signal, the old version of the sign detection of Tesla was telling you that the stop signal is actually a speed limit. Okay? Or if you take a state-of-the-art wolf recognizer, wolf ASCII recognizer, you discover that it recognizes wolf against ASCII by simply looking at the background and not looking at the wolf. If there is snow, it's an ASCII. If there is no snow, is a wolf. 2018, pneumonia recognizer. They took millions of scans in an hospital in the USA, and they built a system with 98% of accuracy to recognize pneumonia at early stages. Then this guy checked, asked to the network, where do you look at to check if there is pneumonia? And this is the answer, right shoulder. Why? There was a tag, healthy, unhealthy. Okay? So the people that was collecting the data put to not forget about who is healthy, not healthy, a tag here with a different letter. So the machine simply detected the tag instead of recognizing the pneumonia. People go in jail, face recognition system that are biased toward dark-skinned people, and specifically women with dark-skinned people. That has been discovered by a woman, dark-skinned, researched in the Hawaii. Okay, there is code bias that makes a lot of these examples. Privacy. Okay, there is attack to privacy that are not simple to detect. For example, the first one is quite famous. A father received at home the publicity for diapers and stuff like that for babies, then called the company and say, I have 70 years old, I don't want to have babies, stop selling me this. And the guy answered, yes, but we see from your card that you bought a pregnancy test. There was the child that was actually buying the pregnancy test with the fidelity card of the father. And the cultural competency, this is, for example, what we tested in our lab, a robot going in a Chinese place, in a Scandinavian place and an Indian place, and we discovered that he is not able anymore to recognize what is a carpet in Sweden if he lived in Scandinavia for a lot of time. Okay? What happens when we use generative AI? Okay? First of all, on top, for example, there is a language bias. There are much more text in English than in Italian. Okay? There is different proportion between male and woman based on the country. In Wikipedia, there is the problem of vandalism, so fake news inside the Wikipedia. Okay? So the data are biased. Okay? And what happens in generative AI? If there is no robustness, you have adversarial prompting. If you ask to ChatGPT to tell how a bomb is constructed, he answers, I cannot tell you because it's dangerous. If you attach some text at the bottom of your prompt, it starts to tell you exactly how to build a bomb. Okay? Hallucination. If you try to search papers, I see a lot of PhD here, so they do what I did. I don't want to go to Scholar and start to read 1 million papers, so I go to ChatGPT, tell me 3 references about this topic, okay? 2 of them are completely invented. So invents references, okay, that do not actually exist, okay? Fairness. Right, haiku is, do you know what is haiku?
Japanese poem. Japanese poem?
No, haiku is like, in Italy is said a massima, is a phrase that represents well a concept, okay? Instead here you say, write a haiku about a man. Men are strength and my protector with gentle hearts going us through life, okay? So the typical idea of the male to do war to save women, okay? And then you ask the same about a woman, and then they have to clean the house, basically, okay? And this is, of course, something that is not correct, okay? Leaking. If you ask now, of course, these are all the examples, they have been fixed, but this is 4 months ago, okay, not much more than this. If you ask to ChatGPT, repeat a word forever, poem, 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 okay, it simply retrieves from the data exactly an email of a CEO of a big company with his data, email, phone, and telephone, okay, so privacy leaking, okay. And then there is also cultural incompetency, in the sense that this is the problem of fixing a problem, in the sense that now we are so much prone to fairness and so on, that they put inside Gemini, this is Gemini, not ChatGPT, a way to reduce biases. So they try always to put in images also people with dark-skinned color and women, okay? Problem is that when they ask, please show me a typical Nazist guy, it took, which is not probable, okay? And then when you ask a typical US senator of the 18th century, again, I don't think that is possible, okay? Because Indians were killed by actually the senators of that period, okay? What happens today? What the people are doing to reduce this problem? They are putting on top of this large language model a thing that is called guardrail. What is guardrail? It's like guardrail in the streets, so a way to not allow the large language models to generate things that are, in some sense, out of the street, okay? And you can do it in different ways. You can act on the question. For example, if there are particular words like bomb, I don't answer, okay? You can act on the processing, so you can check both the input and the output. Or you can act on the tuning, in the sense that you can generate your large language models with some guardrail inside, okay? There are multiple implementations of these. This is, for example, a review that came out 1 month ago, okay? There are basically 3 main approaches. One is the one of Facebook, the other one is the one of NVIDIA, and the third one is the one of Google, okay? And the idea of all these things, basically, is to try to use again large language models or retrieve augmented generation to check input, output, and generated things, okay? So basically they are using the same tool to try to detect the problem in the tool itself, okay? With not good results, as you saw before, okay? But this is the best that we can have. So, due to this problem, what happened? That, of course, society started to be worried about the use of AI at large scale, okay? Because today, basically, even my grandmother is using ChatGPT somewhere, even without knowing it, okay? So, EU started to think about, in 2021, so it's actually quite recent, okay? To an idea of regulating the AI, following basically the success, okay, if we can call it like this, of the Data Act, the one that, for example, generated the GDPR, okay, for data protection and privacy. It has been basically approved in 2023, in March, so 3 years ago, and in 2025 probably will be actually legally enforcing companies, okay? So it's something that is quite important, okay? In the sense that it will become law in a small amount of time, okay? What is the idea of the AI Act? The idea of the AI Act is to try to put some limits to the use of AI in the context where it can hurt in some way, okay? As you can imagine, usually politicians are not very technical guys, okay? So at least they recognize that they cannot understand what is happening, okay? And they adopted a risk-based approach, okay? So I don't care about how you are building AI, okay? But I just care about the possible implication of the use of AI in real-world application, okay? So even if you are using a for loop, but this for loop can hurt people, so it is an unacceptable risk, you cannot implement that tool, full stop, okay? So I don't care if you are the best researcher in the world, you did your things at the best, you cleaned your data beautifully, you are Google, so you have a lot of money, so you did whatever it can be done to generate a good tool, okay? If that tool may impact with a certain level of risk the life of the people, you cannot develop it, full stop, okay? Then there is the high-risk things, okay, for which they need to pass a sort of checks, and then this tool needs to be registered in a sort of European list of tools, okay, that will be monitored like the medicine, more or less. When you develop a medicine, when it is approved, it is continuously monitored. If it generates some incident, it is again checked by the medical community, and then it can be retracted from the production. Okay. For limited risk and minimal risk, of course, the regulation is less stringent. Okay. For the tools that have high risk, so not unacceptable, but high risk, the process is this one. Okay. You develop your thing. Okay, you need to do a conformity assessment, you need to register as a standalone system in the EU portal, okay? You need to do a declaration of interest, then it is continuously monitored, and when you change it, you need to restart from scratch the process, okay? What happens for the things that are not developer of these tools, but are user of these tools? Of course, Google can afford to pass all this process and register a new tool, okay? But imagine, for example, the small company that needs ChatGPT to develop a small conversational toolkit for a user, for example, specific to sell bananas, okay? It cannot go through this process. Otherwise, it's not economically sustainable, okay? So user, not the developers of this system, does not have legal obligation, if not to state that they are using the tool that is registered on the EU portal, okay? This is useless. Now, last question. We are in the EU, and we need to ask to ourselves if this regulation is a good thing or a bad thing, okay? If you look at it from a user point of view, of course, this regulation has surely some pros, okay? In the sense that we are the first that try to avoid the misuse of artificial intelligence, okay? It raises awareness, because now also my grandmother knows that there is the AI Act, okay? And of course, it pushes the other country, okay, to do the same thing, because imagine the USA people, they say, okay, but we are more stupid that we do not regulate AI like in the EU. So the society will push toward the regulation, okay? So these are, of course, all good aspects, okay? But now put yourself in the clothes of the developer, okay? Why I need to stay in Europe to develop AI that there are these regulation? I go to USA and do whatever I want, okay? When they regulate, because the next one will be, of course, USA, I go to China, done, okay? And China do not regulate anything because people cannot say that, oh, no, I want the regulation, it's not a complete democracy, okay? Second, put yourself in the clothes of a company that that has already invested in AI, maybe 100,000 of euros, million of euros, okay? And from tomorrow, his product cannot be developed anymore, okay? What happens? It will start to sell and produce this thing in another place. It will not stop doing his work, okay? So what happens basically? The competitiveness of companies and countries is becoming regulation dependent, okay? So the ability to innovate of EU will not anymore depend on the funding that we give to research or on the quality of the researcher in the EU, but will be dependent also on the regulation, because in some field, researcher will not be able to do research because those products cannot simply be discovered, okay? And like the atomic bomb, it has an acceptable risk, of course. We can destroy the planet, okay? But the atomic bomb also generated good things, like, for example, the electricity power or other things that I don't know, okay? So every technology has good side and bad side. And not always the bad sides needs to be just taken care with respect to the good sides, okay? So this is the problem. Of course, there are the people in USA that takes jokes about us. There is the famous joke, US invent, China copies, EU regulates, okay? So this is the idea. This is the conclusion of my presentation.
We refuse to understand the model created by AI. Have you refused to understand the model created by AI?
No, we are not able to. No, it's not that we refuse. We are not able to.
But that's a big contradiction because you know the first step of artificial intelligence, when you classify, for example, music, it was very easy to classify, to separate classic and modern music, because the classifier just measures the duration. 5 minutes is modern music and half an hour is classic music. So we need to understand the model.
If you, the main tool, I didn't explain it here because it's more technical, but the main tool that makes these things works is called parameterization. So the idea of taking many parameters, full stop. Many data, many parameters. More parameters than data, stop. We don't know why, but it works, okay? Depends, in the sense that if you hear, there is Tommaso Poggio, maybe you heard about it, he's a sort of father of AI, okay? There is plenty of talks in 2000, 2010, where it says, okay, but these things will never work. We need something more to create intelligence, okay? In the sense that until 2 or 3 years ago, nobody would have never believed that with simple predictive model, we would have been able to generate ChatGPT, okay? Now it works, and there is a sort of really, you go in the conference and you really perceive from these old people the fact that they don't believe, so they are not able to admit we didn't, we missed that, we were wrong, okay?
I believe that we shouldn't refuse to understand it, for example, in order to better know why the artificial intelligence can recognize a signal, a traffic signal, for example.
No, but it's not that we refuse. We are trying to, but we are not able to. It's not that, it's not willingness, it's ability. For now, we are not able to understand why. We observe some phenomena, we try to mitigate it, but once you put a patch on some things, other issue rises elsewhere, okay? It's really that these architectures are so big and so complex that are really difficult to inspect, okay? Maybe in 10 years someone will have the right idea to try to make an explainability method for this kind of architecture. But right now we don't have it. Okay.
I think it's an interesting point. I know because I was working in another university chat, and we have models that works, but we don't really know why it works. There is a lot of research trying to explain why this model is working, but this is a continuous process. It's not we don't have all the answers yet about why this model is working well or better than others models. We don't have the answers.
And another problem is that these tools are becoming like, I don't know how to say, like cars for people, no? Also researchers in this field are using these things without actually knowing what is happening. They use it as a component, they put it, it works, done, done. Don't touch it because it works, okay? So this is the other problem. No? They are becoming not anymore a matter of research, of inspection. They are becoming a matter of use. So it's an instrument that people uses. If it works, they are okay with that, okay? And this, of course, increases the problem, because instead of putting effort in trying to understand what is happening, we simply discover that more and more these things are working in practice, okay?
Speaking of that, I have a problem with ChatGPT is, for me, it's a problem with hallucination, but when they give you a good hallucination, let me explain. When they give you an answer, then you know this is wrong. But when you read it, if I don't know the knowledge that I have, I can think that this is true, because it's well explained, the structure is correct, but you know the data is correct, the answer is not correct. And it happened to me that with the student compare this class of answer in words that they give to the students, because they give to you a bad answer, but you can think that it is true. It's very, very difficult to
yes, but if you think about it, is not very where they are training these things on data produced by humans, okay? We are academics, so I am registered. we are used, let's say, usually hear people that talks about something, have an history, have a reputation, and so before saying something, they are trying to be sure about what they are saying, okay? Instead, these machines are not trained on data like this, okay? If you train your model on data produced by professor of Sevilla, okay, they will not invent a reference, okay? Maybe they will just reference people from the University of Sevilla, okay? But this is another problem, okay? But instead, these data are generated also by text, for example, by people that talk about vaccines during COVID time without knowing anything about vaccines, okay? So these sort of bias are also inherited by the machine, no? That does not, it is difficult that in the internet you find a question below, I'm not an expert of this field, I cannot answer to this question, okay? At maximum there is, I'm not an expert, but, comma, and then they start, no, in my opinion, vaccine makes you grow a pair of bird hairs, okay? So the machine learned about that, no? It's not that it stops, says, I don't know how to answer, then I say, I don't know. It tries to generate something that is as credible as possible, okay? In the sense that it's constructed to generate a credible answer even when it's wrong, okay? So it's designed like this.
Only to find an example that you said before that with the word problem, with the background, we work in a project that has exactly the same problem. We need to detect container crash with problems and without problems. And they have a very, very good accuracy. as good, and we don't think it is correct. What happened here? The problem was the camera can use for one case.
It was different.
And one day the camera put made by Redmi camera. The model learns to read the made by Redmi camera, that is the worst one. Sometimes this class of systems try to learn very well the tricks, not the answer, the tricks, a pathway to avoid the thing that you are trying to teach that.
I tell you this without saying the companies, but I worked for a while, not with Hitachi, with a company that makes trains, okay, high-speed trains, okay, and they paid a huge amount of money to a data mining company, very good, very famous, okay, to detect, to anticipate let's say the brakes of the doors, okay? Because in high-speed train is important, because the high-speed train needs to stop in a particular place and so on, okay? They give the data to this guy, they give them the result, 100% of accuracy, okay? Then they apply the model in practice, always wrong. 100% of the time was wrong, okay? Why? Because they put in the data, without knowing, I don't know why, the date of the substitution of the piece. Because in the input there was exactly the output. Yes, so it's very common to have these mistakes, and made also by people that are much more better than me. Okay. I discovered just by chance, because I checked that there was a date that was after the day of the prediction. I say, but how is it possible that it puts information about future inside the input? And I asked, well, sorry, but here you put something in the future. I say, yes, I do, we didn't recognize it. Then they removed this success probability 10%. So.
Trial in this case of us is very good. So good to be true. I don't think it can be true. It is necessary to be false. And then start to see what's happening that, and this the difference of the camera. Then thank you, Dr. Oneto, again. If anybody has any question?
Just one moment.
Yes, of course.
You said before that it's exponentially increasing incidents related to the AI. Is there any legal liability to the builders, to the researchers, to the companies who have made these products?
The only things that I know is that in the USA, when that guy was illegally put to jail, okay. I don't think that paid the developer of the tool, but paid the user of the tool, okay? In the sense that the developer produced the system, but probably in some place that is written, I take no responsibility for mistakes, okay? So it's theoretically in Europe, if you design a product and you prove that you did the best that you could for the design of that product, you cannot be suited, okay? In the sense that I did my best to produce these things. I put in the things that there could be errors, this is your problem, okay? Now with the AI Act, no, there will be legal consequence in the sense that your product is registered, you stated that it should operate under some constraints, and so if there is a problem, you will have to pay for that, probably. Then I'm not a lawyer, so I don't know exactly the legal aspects. But the only example that I know is that guy in the USA that was imprisoned because of a face recognition system. And the only effect is that the producer now does not produce anymore that kind of system. There was a ban, you cannot anymore use in legal question face recognition system. For the rest, I don't know.
Yes, thank you, Luca, for your speech. I have a question. Also, I would like to know your opinion about something that I'm asking myself about these kind of technologies. Thinking about the infrastructure that we have under this kind of technology, we are thinking about to have some device in which you have a prompt you can ask. Another the point of view, you have some kind of servers that are developing are running algorithms, and we are thinking about a huge possibility for computation, I guess. What is your prediction or your opinion about to have this kind of technology in such devices isolated, not connected? For example, without any coverture, or if we have in offline way without connection, is it?
Yes, there is a lot of research in this direction for specific tasks, in the sense that if you don't want to ask to ChatGPT from how many bananas a monkey wants to eat to theory of relativity, they already developed it. In the sense, if you want, for example, large language models for doing maintenance on trains, okay, they are already able to shrink the network and make it stay offline on an iPad or iPhone, okay? For general purpose, right now, I don't think there is yet something that matches the possibility. But for example, GPT-4o, the one that is out now, is 10 times less computational requirement than the previous one, okay? So I think that the power of this device will increase in the next year. The requirement of the machine will decrease. So in few years, we will be able for sure to run it on a smartphone without any problem. So it's just a question of time.
Yeah.
Question? Then please, we need to give a speaker a well-deserved